Okay, this is 4.2 of algebra. So in a relationship between variables, the dependent variable changes in response to another variable, the independent variable. So when you're independent, you're on your own, right? You decide things, you do things. Doesn't matter what other people do. So the independent variable is on its own. It's going to be its number, wherever it wants to. And the dependent variable changes based on the independent variable. The independent variables are called the inputs, and the values of the dependent variables are called the outputs. So, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So we start with one rectangle, and its perimeter, remember this would also be a 6, and this would also be a 1 down there. So this perimeter would be 14. Those would be 1 and 1. So 6 plus 6 is 12, plus 2 is 4. So this would give me 16. 6, 1, 1, and 1. So again, I've got that 6 and 6, which is 12. Plus 3 is 6. So that's 18. That'd also be a 6. 1, 1, 1, 1. I got that 6 and 6, so that's the 12 again. And then 4 plus 4 is 8, so that'd be 20. Right, so perimeter is around the edge. So I add those up. But here's putting that into a table. So we're going to use x as the number of rectangles, and y is going to be the perimeter. So number of rectangles are here. These are equations for the perimeter. Equation for a perimeter is 2 times the length plus 2 times the width. So we plug in, so the this here are the ones that are changing, right? So I sketched it out over here. When there was just one rectangle, it was only 1 across. When there were 2 rectangles, it was 2 across, right? So that's what this is calculating out over here. And this 2 times 6 is the fact that we've got 6's on both sides. And that stays constant, right? We don't ever change how tall they are. So once you get your answers, those are going to be your y values. So you see that in the ordered pairs there. So in words, multiply the number of rectangles in each figure by 2 to get the total length on the top and bottom sides of the combined figure. Then add 2 times 6, or 12, for the total length of the left and right sides of the combined figure to get the entire perimeter. So, if you look at our work out here, our math up here, this is the part that's always changing, right? The part that's changing, that's where we put the variable. Every time you're adding 12. 2 times 6, you're adding 12. And you're always doing 2 times whatever number. So that's how they get their equation here. Y equals 2x plus 12. 2 times something plus 12. And then we can graph those points. So let's try this on our own. Oh, one thing though. The x is always our independent variable. The number of rectangles doesn't change, right? The perimeter depends on how many rectangles you have. So the y-axis is the dependent variable. Okay, so we've got our own geometric pattern here. I'm just going to go through and calculate what the perimeter is first before we actually stick it into a table. So this one here, we've got 3 plus 4, and that's 6 plus 4, which is 10. Here we've got 3 plus 4, and that's 14. We've got 3 plus 4 plus 4, which is 18. I've got 3 plus 4 plus 4 plus 4, which gives me 22. So just looking at this already, I've got that 3 plus 3 in every single one, right? So I'm going to set up my table. My x value will be number of triangles. So we do 1, 2, 3, and 4, right? 1, 2, 3, and 4. And then this is going to be the perimeter. Run out of room there. So I've got my work up here. I could simplify this a little bit, right? The 3 plus 3, instead of the 3 plus 3, let's just call that 6. 6 plus, well, this one has 1 4. This one has 2 4s. This one has 3 4s. This one has 4 4s. And that matches up with the number of triangles. So I could rewrite this as 4 times 1, right? Somehow I need to get my variable x in there. And we said that gave me 10. So this one is going to be 6 plus 4 times 2, which gave me 14. This should be 6 plus 4 times 3, which gave me 18. This should be 6 plus 4 times 4, which gave me 22. These are my y's. So then my ordered pairs are 1, 10, 2, 14, 3, 18, and 4, 22. Okay. So there's my table. They also wanted me to do it in words, so I'm just going to say this out loud instead of writing it all out. So we take the number of triangles and we multiply it by 4, right? That's what's happening here. And then we add 6 to that number to get the total perimeter. So in an equation, every time I'm adding the 6, that never changes, right? So I've got 6 plus, and remember, we need the variable where the numbers are changing. So in the parentheses, that's where my numbers are changing. And every time I multiply by 4. So this is 4x. And then I can graph it. So 1, 2, 3, 4. I'll number my graph. And I'm going to go up by 5s here. So 5, 10, 15, 20, 25. So it's not perfect, but it'll get us a good approximation. So 1 and 10, 2 and 14, let's go a little further, 14, 3 and 18, and 4 and 22. Approximately there. And it looks like a straight line, so that's good. It's going up by the same amount each time. Okay. A function is a relationship that pairs each input value with exactly one output value. So whenever I plug in the number 2, let's say when I plug in 2, I get 3 out. Every time I plug in 2, I need to get 3 out. I can't plug in 2 and then I get 5 out. That's not a function. No surprises involved in function. Whatever comes out should be what I'm expecting every time. A linear function is a function whose graph is a non-vertical, means not up and down, line, or part of a non-vertical line. Okay, so when we have a table, we can check how much we're going up and how much we're going down by. This is a linear function because it goes up by the same amount, it goes down by the same amount each time, right? As it goes up by 1 over here, it goes down by 3 over here. I can write that as an equation, so I've got y equals 512, how much I started with, minus 3x, because that's my difference. And then we can graph it. See how they jumped from 0 to 500 here? If you're going to do that, that's okay, but you need to put what they did, the little squiggly there. So when we're doing our graphs, they might look like that. A squiggly so that we know that you jumped. Okay, so the first thing we're going to do is we're going to find the differences. So in between here, we add 1. In between here, we add 1. In between here, we add 1. Here, we add 2, add 2, add 2. So, every time our x goes up 1, our y goes up 2. So I can write this equation as y equals how much I started with. I started with 8, right? And I add 2, and whatever your difference is, you always stick the x with that. So plus 2x. And I can double check to make sure this works. Y is equal to 8 plus 2 times 0. Well, that's 8 plus 0, and that's just 8. And that works, right? When I plug in 0 for x, I get out 8 for y. Let's try it with one other number. Y equals 8 plus 2 times 1. That's 8 plus 2, which is 10. When I plug in 1, my answer is 10. That's correct. That's right there. And there's your homework.